In the previous video, we discussed systems of linear equations, specifically the conceptual understanding, not actually solving them. So in this one, we're going to go ahead and actually try to solve it. And we're going to go over two methods. The first video is going to be on solving them using substitution. The next one will be using combination. So what is substitution? So let's say we have, here are two equations. We'll have x, we'll keep this really simple. So x plus y equals 10. And you're given that x equals 4. So just like in a sports match, when you substitute one player for another player, we have two conditions, and here we know that x is equal to 4. So we're going to replace this x with this piece of information. So we're going to say 4 plus y equals 10. Now to do that, we use this piece of information, which is why this is called substituting. And that's the method in a nutshell. So from here we could figure out subtract 4, y is equal to 6. That's it, we're done. So x is 4, y is 6, and we've solved this problem. So that's the basic example of how to substitute. Now let's go to something a little more involved. So let's say we have 2x minus 3y is 5, and x plus y is 10. All right, so usually if you're doing this, you want, first of all, you want to assess, should we use this method or the method in the next video? That's another point. Should we start here or here? It's better to start here because this looks simpler. In other words, there's only one x, one y, there's no funky, weird numbers in front of them. So this will be easier to rearrange. So it doesn't matter which way we're going to go. We could solve this for y, we could solve this for x. Let's solve this for y. So we'll say y is equal to, we're going to move the x over, 10 minus x. All right, so that means from the second equation, we're going to use this condition. So that's our substitution. So wherever you see y, we got this from here, so we're not going to plug it back into here. We're going to plug this back into the first one, which we haven't used yet. So let's replace y over here with this. So we have 2x minus 3 times. Now instead of y, we're going to replace y with this. All right. So before we even solve this, notice the only variable here is an x, which means it's a simple equation with one variable. So 2x minus, distribute the 3, 30, negative, negative is positive 3x, and that's 5. So here we have 5x. I'll move the 30 over, so that's 35, so x is 7. And now we can plug x back into here, so therefore y must be 3. Now at this point, you're pretty much done. However, if you want to be sure you've gotten it right, let's just double check our answer. So if we plug 3 and 7 into here, that is indeed 10. But let's also make sure that the first equation works. So 2 times 7 is 14, minus 3 times 3, which is 9. So is 14 minus 9 equal to 5? Yes, it is. So this works. The reason you want to plug it back in is that you may have made a mistake in doing this. And so let's say we got an 8. Or let's say we got 8 and 2. Maybe that worked over here, but you plug it back in here, doesn't work. So that's going to tell you made a mistake. All right, so that's sort of the basic way you would use substitution on a system of two equations. Now let's see what happens if this is a little harder. So let's say this is 4x plus 5y equals 7. Now, the great thing about substitution is it almost always works, but it may be really difficult to use it. So this will be an example where we could still use it, but you'll see that it's going to be very tedious, and this will inspire us to introduce a new method in the next video. So let's say we're going to use this equation. It would probably be easier to use this one because the numbers are lower, but let's just use this one and we'll solve for x. So we're going to move this over. So 4x is 7 minus 5y. X is 7 fourths minus 5 fourths y. We could also just keep all of this over 4, so you could write it this way or that way. It doesn't really matter too much. All right, so then we're going to substitute this for x over here. So we're going to have 2 times that whole thing minus 3y equal to 5. Now notice everything is in y's now, so we'll be able to do this I want to emphasize 2 points. So A, that we can do this, and B, that it's sort of unpleasant and kind of annoying to do this. All right, so the 2 over 4 gets simplified, that's over 2. So let's split this apart. So it's 7 over 2 minus 5 over 2y minus 3y equals 5. So we're going to have 7 over 2. That's going to be negative 2.5 minus 3, so that's negative 5.5 y equals 5. Let's move this to the right and move the 5 to the left. So we're going to have, except I'm going to write it right equals left instead of left equals right. So 5.5 y equals, what's 3.5 minus 5? That's negative 1.5. All right, now all of these halves are driving us nuts, so let's convert these to improper fractions. So that's going to be 11 over 2y equals negative 3 over 2. We can multiply through by 2, so the 2's are gone. And we have 11y is negative 3, so y is negative 3/11. So notice how in this problem the numbers are much uglier. Now, if you want to find your x, no pun intended, you're going to plug this into anywhere you want. So we could plug it into here. So then x would be 7 minus 5 times whatever y is over 4. Now that should say a 4. That looks like a y, but that's a 4. All right. I won't even bother doing this calculation. You guys get the idea. We're able to find our y, we're able to find our x that are going to satisfy both of these equations. However, it was kind of a lot of work. There's a lot of fractions. It's very tedious. But substitution always works. So if you're completely clueless, go with substitution. But in the next video, we'll discuss how to do this a little less painfully. All right, see you guys in the next video.